mission objective demonstration of rendezvous, docking, undocking, and power transfer takes place. The mission will be a forerunner for autonomous docking needed for future lunar missions like Chandrayaan-4, ISRO's ambitious program of building and operating of Bharatiya Antariksha Station. Through this mission, India is marching towards becoming the 4th country in the world to have space docking technology.
अब हम उड़ान से ठीक 1 मिनट 30 सेकंड की दूरी पर इसरो यह क्रांतिक प्रयोग भविष्य के मिशन जैसे अंतरिक्ष यान रखरखाव, स्पेस स्टेशन संचालन, अंतरिक्ष ग्रहीय मिशन जैसे अंतर्ग्रही मिशन जैसे चंद्रयान, गगनयान आदि मिशनों में स्वायत्त डॉकिंग तकनीक का अग्रदूत होने जा रहा है। यह तकनीक आज कुछ ही देशों के पास है, जैसे यूएस, रशिया और चाइना। इस प्रयोग के पश्चात भारत भी उन चुनिंदा देशों में होगा जिसके पास यह तकनीक होगी। अब हम उड़ान से 50 सेकंड की दूरी पर
-45 seconds, -40 seconds, -35 seconds, -30 seconds,
real-time programs activated,
-25 seconds, -20 seconds, -15 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Liftoff normal.
That's a marvelous liftoff of PSLV-C60 SpaDeX mission on the go.
Plus 15
Sleek
seconds.
PSLV core-alone vehicle saluted against the night sky, a beautiful sight to behold.
जी हाँ, अभी आपने देखा सफलतापूर्ण उत्थापन PSLV-C60 रॉकेट का रात को रोशन करता हुआ PSLV-C60 अपने उद्दिष्ट कक्षा की ओर
ट्रैकिंग
सभी तंत्र सामान्य निष्पादन करते हुए रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की है। प्रथम चरण का निष्पादन पूरी तरह सामान्य है। प्रथम चरण का कुल कार्यकाल लगभग 111 सेकंड का होगा।
Plus 1 minute.
ट्रैकिंग
S139 motor currently thrusting, developing 4,800 kilonewtons thrust. Its 138-ton solid propellants take 111 seconds to deplete.
स्टेज परफॉर्मेंस नॉर्मल।
आसमान पूरी तरह साफ, इसलिए दूर तक हम देख सकते हैं। इस बार प्रथम चरण का प्रतिकन भी पूरी तरह साफ दिखाई देगा हमें।
Shah station currently tracking the rocket.
First stage separated, second stage engine started, closed loop guidance initiated.
प्रथम चरण के कार्यकाल के पश्चात उसे सफलतापूर्वक पृथक कर दिया गया है यान से तथा द्वितीय चरण PS2 स्टेज का प्रज्वलन शुरू हो चुका है।
The second stage has commenced its operation after the first stage separation. This stage burns on hypergolic earth-storable propellant combination of hydride of unsymmetrical dimethyl hydrazine and dinitrogen tetroxide. The legendary Vikas engine developing 800 kilonewtons thrust in vacuum.
यान के सभी तंत्र सामान्य प्रदर्शन कर रहे हैं और यान उद्दिष्ट कक्षा की ओर बढ़ रहा है। यह द्वितीय चरण है जिसका कार्यकाल लगभग 150 सेकंड का होगा। इस दौरान वह 800 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है और इंजन जिम्बल के मदद से दिशा निर्धारण किया जा रहा है। इस दौरान
Plus
यान
3 minutes.
क्लोज लूप गाइडेंस के अंतर्गत काम कर रहा है। कुछ ही क्षणों में हम पेलोड फेयरिंग यानी ऊष्मा कवच का पृथक्करण देखेंगे।
Payload fairing separated.
That's the next major flight event achieved, the separation of payload fairing.
Second stage performance normal.
प्रमोचन यान अब घने वातावरण से बाहर जा चुका है। अब इसकी ऊंचाई लगभग 130 किलोमीटर हो चुकी है, इसलिए ऊष्मा कवच की अब कोई आवश्यकता नहीं है। इसे यान से पृथक कर दिया गया है।
The second stage operation lasts for 151 seconds and will be jettisoned 4 minutes 20 seconds into flight. Shar and Port Blair stations tracking currently.
द्वितीय चरण तरल
4
पर
minutes.
आधारित चरण है। इसमें लगभग 42 टन तरल नोदक का प्रयोग किया जाता है। अब इस गतिविधि में अगली घटना होगी द्वितीय चरण का पृथक्करण तथा तृतीय चरण का प्रज्वलन शुरू।
Second stage separated. Third stage ignited.
We are 4.5 minutes into flight and the third stage has commenced
Third
its
stage
operation.
performance normal.
द्वितीय चरण को कार्यकाल के पश्चात सफलतापूर्वक पृथक कर दिया गया है तथा तृतीय चरण ठोस नोदक पर आधारित तृतीय चरण इसका प्रज्वलन शुरू हो चुका है। पूरे तंत्र पूरी तरह सामान्य कार्य करते हुए
Third stage of PSLV operates
Plus
on
5
7.6 tons of HTPB based solid propellant. Vacuum thrust close to 240 kilonewtons and close to 2 minutes burn time.
PSLV का यह तृतीय चरण HPS-3 चरण के नाम से जाना जाता है, हाई परफॉर्मेंस PS-3 स्टेज। इसमें कुल 7.6 टन का ठोस नोदक और इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है।
Third stage performance normal.
तृतीय चरण को सतीश धवन अंतरिक्ष केंद्र द्वारा निर्मित किया जाता है।
Trajectory of the rocket closely following the prediction.
Plus 6 minutes.
यान पूरी तरह अपेक्षित पथ का अनुकरण करता हुआ अब तृतीय चरण अपने अंतिम कार्यकाल की ओर।
Third stage action completed.
The third
Vehicle in
stage
combined
has
hosting approximately for 125 seconds.
during the coast phase along with Shar and Port Blair stations. The tracking station at Singapore also starts to acquire the tracking and telemetry data.
तृतीय चरण का कार्यकाल समाप्त हो चुका है। इसके पश्चात कोस्टिंग फेज की शुरुआत हो चुकी है। यह कोस्टिंग फेज
Plus 7 minutes.
25 सेकंड का होगा। इस
Vehicle
दौरान
performance
बिना किसी
normal.
प्रबंधन के यान सिर्फ दिशा निर्धारण करते हुए अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है।
As a precursor to rehearse for Gaganyaan mission, 11 ground stations will support for PSLV-C60 launch vehicle for orbits 1 and 2.
पूर्वी दिशा का यह मिशन है, इसलिए ग्राउंड स्टेशंस में शार, पोर्ट ब्लेयर, सिंगापुर, यत्रगा, शेटलैंड यूके, प्लाना और मॉरिशस स्थित ग्राउंड स्टेशंस इसे ट्रैक कर हम तक डेटा उपलब्ध कराएंगे।
All right,
Plus
another
8
success we have there from ISRO launching SpaDeX, which is space docking experiment, and this is going to make projects like Chandrayaan-4, India's space station called Bharat Antariksh Station, a success. Whenever those projects are launched, this is going to be a contributing project into those bigger ones. Niranjan, and joining us over the phone, Minister for the Department of Space and Minister in the Prime Minister's Office, Jitendra Singh. A very good evening to you, sir. And another success for ISRO.
उसने आपकी कॉल को
Mr. Singh, good evening. Can you hear us, sir?
Operating.
जी हाँ, कोस्टिंग फेज समाप्त हो चुका है। तृतीय चरण को यान से पृथक किया जा चुका है तथा इसके पश्चात चतुर्थ चरण PS4 स्टेज का प्रज्वलन शुरू हो चुका है और सभी तंत्र सामान्य कार्य कर रहे हैं।
We are 9 minutes 15 seconds into flight. Current altitude 417 kilometers.
जी हाँ, अब यान की ऊंचाई 423 किलोमीटर हो चुकी है तथा सापेक्ष गति 6.39 किलोमीटर प्रति सेकंड। उद्दिष्ट कक्षा के लिए यह ऊंचाई 476 किलोमीटर की होनी है तथा सापेक्ष गति 7.3 किलोमीटर प्रति सेकंड की प्राप्त करनी बाकी है।
This stage will operate for 271
Stage
seconds,
performance normal.
during which the rocket will ascend to 80
Plus 10
kilometers
minutes.
in altitude. The relative velocity is enhanced from 6.2 kilometers per second to 7.3 kilometers per second. At 13 minutes 12 seconds into flight, the PS4 shuts off.
PSLV-C60 SpaDeX मिशन में SpaDeX A तथा SpaDeX B नामक दो अंतरिक्ष यानों को 476 किलोमीटर की गोलाकार कक्षा में 55 डिग्री के झुकाव के साथ प्रक्षेपित किया जाएगा। इसमें SpaDeX A तथा SpaDeX B दोनों ही लगभग 220 किलोग्राम के हैं। PSLV की सटीक प्रक्षेपण क्षमताओं का प्रयोग करते हुए इन दोनों अंतरिक्ष यानों को कम से कम सापेक्ष गति के साथ यान से पृथक किया जाएगा। यान से पृथक होने के बाद इन दोनों उपग्रहों को, जिनमें एक को टारगेट तथा दूसरे को चेजर अंतरिक्ष यान का नाम दिया गया है, इनके बीच लगभग 30 किलोमीटर का अंतर होगा। यह अंतर कम होते हुए 20 किलोमीटर की दूरी को टारगेट यान से मौजूद प्रणोदन प्रणाली द्वारा बनाए रखा जाएगा। फिर सुनियोजित तरीके से प्रणोदन प्रणाली का इस्तेमाल करते हुए चेजर अंतरिक्ष यान टारगेट यान के नजदीक आएगा और यह दूरी जब 5 किलोमीटर से भी कम होते हुए 3 मीटर की हो जाएगी, तब अंतिम में दोनों अंतरिक्ष यान एक दूसरे से जुड़ जाएंगे। इसे हम डॉकिंग कहते हैं। दोनों अंतरिक्ष यानों के जुड़ने के बाद दोनों के बीच विद्युत शक्ति का स्थानांतरण का प्रदर्शन किया जाएगा। इस प्रदर्शन के पश्चात दोनों फिर से अलग होंगे और अपने नियत भारों का उद्दिष्ट कार्य निष्पादन करेंगे। इन उपग्रहों को 2 साल के जीवन काल के लिए अभिकल्पित किया गया है।
SpaDeX mission is ISRO's first endeavor to get 2 spacecrafts to dock in space. SpaDeX has indigenous technologies developed for this mission. Docking mechanism is homegrown. So are the suite of 4 rendezvous and docking sensors. The spacecrafts will carry power transfer elements. The 2 spacecrafts will autonomously communicate through inter-satellite communication link, ISL, incorporated with inbuilt intelligence to know the states of other spacecraft. The novel relative orbit determination and propagation RODP processor used for SpaDeX is GNSS based. It is meant to determine the relative position and velocity of other
Plus
spacecraft.
13 minutes.
The noteworthy thing is due to small size of SpaDeX spacecraft, the precision involved is higher than what is sufficient for a larger spacecraft. Indigenous novel autonomous rendezvous and docking strategy have been developed.
Vehicle in hosting phase before
चतुर्थ
satellite
चरण
separation
को
for 117 seconds.
अब बंद कर दिया गया है। कुछ ही क्षणों में अंतःक्षेपण की स्थितियां प्राप्त की जाएंगी। इस घटनाक्रम में कक्षा में अंतःक्षेपण की स्थितियां प्राप्त होते ही SpaDeX B को सर्वप्रथम अंतःक्षेपित किया जाएगा। उसके 3 सेकंड के पश्चात SpaDeX A को अंतःक्षेपित किया जाएगा।
The fourth stage having shut off.
Plus 14 minutes.
Vehicle is currently coasting.
SpaDeX उपग्रहों में विशेष संवेदक लगाए गए हैं। जी हाँ, अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। कक्षा में अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं। कुछ ही क्षणों में SpaDeX B का प्रमोशन हम देखेंगे।
We are few seconds away from the injection of SpaDeX B spacecraft, followed by SpaDeX A separation, which will take place 3 seconds later.
Plus 15 minutes.
कक्षा में अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
SpaDeX B and SpaDeX A satellites are separated.
जी हाँ, और रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। दोनों मुख्य उपग्रह B और SpaDeX A दोनों को सफलतापूर्वक उद्देश्य कक्षा में अंतःक्षेपित कर दिया गया है।
But mission is continuing for PS4 orbital platform experiment, that is POEM 4, with 2 phases of fourth stage restart. After 2 phases of restart, PS4 stage orbit will be changed to 354 km circular. The first phase of PS4 restart happens in non-visibility period. The second phase of PS4 restart takes place in the visibility period of Shetland in orbit 2. During the non-visibility period, ground trace will be updated by extrapolation on the video wall. The non-visibility period is approximately for 3100 seconds. All the stations involved in operation shall continue in operations. Handing over to Mission Director.
This is Mission Director. PSLV-C60 SpaDeX mission is accomplished with respect to SpaDeX A and B satellites. POEM operations will continue. Thank you.
A jubilant ambience here on the night of 30th December 2024. ISRO has got its own space docking experiment. Do continue to follow the social media handles of ISRO for the updates on the space handshake. Stay tuned for the address by Secretary DOS, Chairman ISRO, Dr. S. Somnath. We take leave from you. Goodbye.
इस मिशन में मुख्य उपग्रह को सफलतापूर्वक अंतःक्षेपित करने के पश्चात यह मिशन जारी है पोयम प्रयोगों के लिए। अब कुछ ही क्षणों में हम इसरो अध्यक्ष द्वारा भाषण सुनेंगे। इसके साथ ही हम आपसे आज्ञा लेते हैं। शुभ रात्रि।
Okay, so that's another picture perfect liftoff for ISRO. Abhishek, we are awaiting the address by Somnath. Let's cut across line.
PSLV-C60 for the SpaDeX mission. The rocket has placed the satellites in the right orbit, which is 475 kilometer circular orbit. That's only one part of the mission, injection of the SpaDeX satellites. Now, in another 15 minutes, the fourth stage of PSLV will change its orbit from 475 kilometer to 350 kilometer lower orbit by first phase of firing. And also, the second phase of firing will be at about 1 hour 20 minutes later after the liftoff. So that process is continuing to enable POEM operations to happen. Further to that, the spacecraft is also going to wait for the solar panel deployment. So the team spacecraft is looking at whether the panels are deployed or not. So we'll get a confirmation soon. So as far as we are concerned, the mission is very well as far as the rocket is concerned. So it has placed the satellite in the right orbit. The SpaDeX 2 satellites are moved. You would have seen in the animation that they moved little one behind the other. So over the period of time, for the days, it will pick up further distance, travel to almost a 20 kilometer distance away. And then the rendezvous and docking process will start. And we hope that the docking process can happen in another 1 week. The nominal time is going to be approximately 7th of January. So I'm waiting for the panel deployment status. I think you have the status?
Yes, sir.
Yes. So I would like to say that the panels of the satellites have been deployed successfully. So congratulations to the entire team of the PSLV project who put the satellite in the right orbit. Also the SpaDeX team who worked a very innovative, novel, cost-effective docking demonstration mission using 2 small satellite bus architecture. So congratulations to them as well. And also two very important parties of this mission is the POEM-4, where we have 24 payloads hosted, which are from the startups, industries, academic institutions, research laboratories, and also from ISRO centers. All the R&D payloads are there waiting for testing in the coming days, in fact in months. So congratulations to them for successful accomplishment of all the mission objectives through the POEM. So once again, thank you. Before I hand over, I would like to request the mission director, Mr. Jayakumar, to speak a few words.
Thank you. Thank you, sir. So, hearty congrats to Team ISRO for venturing into the exciting domain of space docking. This mission is once again a POEM-intensive mission. We have 24 payloads on board, and congratulations to the team who have developed these payloads adhering to our schedules. And congratulations to InSpace for facilitating the delivery of these payloads. This time we are flying the indigenous Vikram 3201 based mission management computer in POEM. Also we have interesting experiments like space robots doing debris capture and inchworm walking, then plasmaspheric and electron density measurements. 3 biological experiments are there, advanced inertial sensors, green propulsion systems, etc. And this month, in fact, we had 2 launches of PSLV from the same launch pad, that is the first launch pad. So after the first launch, the SDSC team, SHART team, was very quick in refurbishing the launch pad. Special thanks to them, and also to the teams in VSSC. We also had the movement of the fully integrated vehicle that is up to the PS4 stage from PIF to MST. So let me thank the SDSC and VSSC teams for making this possible. On this occasion, let me thank Chairman ISRO, who is a role model for all of us, and all the center directors for the ardent support provided, and to the mission executives, Sri Damodaran, Chandramouli, Grahadure, Raghavendra, and Surendran, who have worked as a coherent team. I thank all the SDS and SR agencies spread across different centers for their tremendous efforts to make this launch on schedule. Let me take this opportunity to thank chairman and members of Lab, MRR, FRR, ORC, and all the DRTs for the extensive reviews and clearing all systems. I place on record our deep appreciation for our industry partners for the key role they play in realizing different systems and carrying out the integration of the vehicle as per schedule. Let me also thank my own PSLV project team for their tireless efforts put in for the past few months. Thanks to the admin and auxiliary staff who have supported our campaign activities. Finally, I thank our dear family members for understanding us and providing wholehearted support for keeping our mission successful. Wishing all of you a happy new year 2025. Jai Hind.
The concept of the docking experiment in orbit has been a long journey in terms of conceptualization, the architecture of these two satellites that came about, and building it over many years of work done by the team at URSC, Rao Satellite Center. The current satellite project director will speak to you now.
Respected Chairman ISRO and our various center directors and distinguished members of our ISRO community who have all assembled here, and my dear colleagues. Good evening to all of you. At the outset, I would like to congratulate our PSLV team for the two successful launches that were in a month. I think it's a record, and for proving that way the vehicle's robustness once again. You have also placed our twin babies in a perfect circular orbit as per our requirement, and I'm happy to share the news that our solar panels are successfully deployed and the strikes out are on their journey, unfolding their wings towards the docking experiment, which is expected to be happening around January 1st week. This mission is very interesting and challenging, not just because of our space docking experiment, the interesting POEM-4 payloads, which are also unique and futuristic in nature. Let me congratulate all our POEM team members, payload team, for their further operation success. On this happy occasion, I would like to, crossing this important milestone of our SpaDeX project, I thank our Chairman ISRO and Director URSC for their valuable guidance and support provided during the entire period. Also, I would like to put on record my gratitude and appreciation to all our earlier program directors, project directors, and project executives for their significant contribution. Also, SpaDeX has undergone a thorough review mechanisms, various review mechanisms. I would like to put on record my sincere appreciation and gratitude to all our committee members, chairmen, for their invaluable effort, guidance, and contributions. As you are aware, the space sector is going through a phase change to enable the private participation in a big way to meet our growing demands, as per our latest space policy guidelines. As an enabler, SpaDeX was assembled, integrated, and tested at an vendor premises for the first time. As earlier, many other industries also have significantly contributed for the fabrication and testing of the subsystem packages. I would like to take this opportunity to sincerely thank all the industry partners for their valuable contributions in growing our space ecosystem. My appreciation to our admin, accounts, purchase, stores, transport, canteen, medical, and maintenance teams for their effort in ensuring all our team members are able to concentrate on their work peacefully. Last but not at the least, I'd like to thank my entire project team for their sincere and untiring hard work, and their family members for their better understanding of the situation. I am sure that with that kind of a support and effort put forth, we will be successful in meeting all the mission objectives of docking, undocking, power transfer, and payload operations. Let us pray and wish for the same. Best wishes to all of us, and happy advanced New Year. Jai Hind.
Thank you, Surendran, the satellite director. Now, what we are all anxiously going to wait is the operation of the SpaDeX docking. I think the very innovative architecture of the docking mechanism and the further mission process have been fully validated using extensive testing and demonstration in Rao Satellite Center. So before we go into that operations, there will be a few days of gap and the operations will happen control center from ISTRAC Bangalore. But before that actual activity happened today, I would like to request the director of Rao Satellite Center to speak about what is going to be happening in the coming few days.
Good evening. Congratulations to everyone for this spectacular and perfect launch of the SpaDeX 01 and 02 satellites into the circular 475 kilometer 55-degree orbit as intended. As Chairman was mentioning, the activity for us starts now. The vehicle has given a small delta V by delaying the second satellite separation by about 3 seconds. And this will, about 10 meters per second rate, this distance will grow. And we are expecting by tomorrow evening, the two satellites will get separated by about 20 kilometers. At this point, we will start using the onboard propulsion system on one of the two satellites to arrest the drift so that we maintain 20 kilometer distance between the two satellites, and like twins, they will be going around in the same orbit with the same speed. We have to wait for 4 days for the appropriate sun orientation for the docking to happen, because in this orbit, the sun is going to go all around the spacecraft body. So we require another 4 days of wait for the sun relative position to come in a favorable condition, so that in the docking orientation, the two spacecraft will generate sufficient power. At this point, again, we will initiate the drift of the two satellites so that the 20 kilometer distance is progressively reduced to 5 kilometers, 1.5 kilometers, like that it will reduce. And after we reach 5 kilometers onwards, we are going to enable the inter-satellite RF link between these two satellites so that the two satellites will talk to each other and exchange their own position, attitude, this kind of information they will exchange, which will enable us to evaluate the software logics which are there in the spacecraft, and also the several new sensors that have been developed by our laboratory for electro-optic systems, Bangalore. These sensors will be one by one evaluated for their fitness for initiating this docking sequence. So docking sequence will start once the inter-satellite distance is reduced to 1.5 kilometers. From there onwards, 3 different algorithms are going to be used, guidance algorithms are going to be used to minimize the propellant consumption, but achieve the required movement between the two satellites without actually deviating too much away, so that the sensors do not lose a line of sight among these two. It's a very innovative way this has been done. And once we reach 3 kilometers, 3 meters, the final guidance algorithm will be initiated, which will be a constant velocity PV guidance, it is called. With the constant velocity of about 10 millimeters per second, the chaser satellite will go and enter into the target satellite. This will be detected by another sensor on board the satellite, which will initiate the docking sequence inside the two satellites. So with the initiation of this sequence, the latches will be released and the clamps on both sides will try to grab each of the satellite, so that from both sides the satellite will try to hug each other.
Okay, so we have 4 guests joining us as we look back at that picture-perfect liftoff and the next few days. The docking itself expected on the 7th of January, as detailed by ISRO chairman. Joining us on the broadcast, Abhishek, Srijan Pal Singh, senior scientist, Dr. Surendra Pal, former director of ISRO. I have Dr. B.R. Guruprasad, who's also a former ISRO scientist, and Dr. Venkateshwara Sharma, former ISRO director, joining us on the show. All right, Abhishek, I want to start with Srijan and then you can take it from there. Srijan, big moment for India, great way to end what has been a great year for them.
Absolutely. What a way to end 2024 and what a way to start 2025. Imagine that, on the 7th of January, we will see our first successful docking. And docking is a very complicated space maneuver. It is something which is extremely important when we are talking about the Bharat Antariksh Station. It is also important for Chandrayaan. So I want to just take half a minute to just explain how important docking and how complicated it is. You see, you've got these 2 huge satellites which are coming close to each other and they are in space. One little error in angle, in terms of the speed at which they come, and space has no friction. So one of the satellites or both of them could just go endlessly in a straight line away from each other, and you can lose them. So it's very complicated. The other problem which can come is that they can also start spinning in uncontrolled way. So not only it could be a linear motion where, if there's a collision, they can just go far away from each other. They can also start spinning. So you have to control both of these things. And that's why docking is important. Now, when we have to transfer, our own astronauts or Gagannauts into our Bharat Antariksh station, when we develop it, it'll be a very important thing to do. When we have to collect samples in Chandrayaan, we'll collect lunar soil samples and send it back into space. There will be a docking, and then docked that Vikram lander, and the propulsion system will bring it back to Earth.
Yeah.
So for all those things, you need docking, and it's a very important day. And it's not just docking, but there are many other things, from robotic arms to evade of space debris. The fact that private sector has participated, universities have participated. For the very first time, India is sending a biological sample, a live biological experiment into space. That is very critical. So all these things is a great way to end 2024 and a wonderful way to start 2025.
Absolutely. And I was going to go to Dr. Surendra Pal, but before I come to you, sir, we have Dr. Jitendra Singh, the Minister of Space, and of course also in the PMO, joining us over the phone. Very good evening, Mr. Singh. Another fantastic launch by ISRO, and that puts us on road to making Gaganyaan, Chandrayaan 4, and of course Bharat Antariksh Station a success whenever those projects are picked up. This is a contributing project to those larger ones. How do you see this small step of ISRO in the direction of interplanetary projects of the organization and of India?
No, absolutely, Abhishek. As you rightly mentioned, am I audible?
Yes, please go ahead.
Yeah, absolutely. As you rightly mentioned, this paves the way for India's accomplishments which are on the lineup for the coming years and also for the next year. I think what is most important is that India has showcased, demonstrated enough to the rest of the world its capability to be a frontline nation in every sector, every sphere of science, and more so in the space technology. We are now, today, have entered into that select league of four nations, India being the fourth one, who are seeking this space docking technology. But even more important is that this has been accomplished absolutely, and totally through indigenous means. The mission is indigenous, technology is indigenous, the effort is indigenous, and appropriately, the entire system of docking that has been used has been appropriately named as Bharatiya Docking System.
Why is Mr. Singh?
This also, I think, is very much in keeping with Prime Minister Narendra Modi's mantra of Atmanirbhar Bharat, and which is also going to pave the way for Viksit Bharat, which is again one of the flagship missions laid down by Prime Minister Modi. Yeah. And as you rightly mentioned, we have in the running in 2025, we have the NAVIC, we have the Vayomitra Gaganyaan. All these missions are going to be hugely facilitated by that, because here we are going to accomplish or master, maybe that will happen on the 7th possibly, because that's our scheduled date when the actual docking happens, which will validate the transfer of articles, the transfer of materials, human, non-human, the power transfer, the payload transfer, even the transfer of astronauts.
True, sir.
Even when the two cars are driving on the highway, you don't expect them to come close to each other and actually sort of, in layman's language, merge with each other and open their respective doors and transfer one passenger to the other and vice versa. Yes. But here it will actually happen, because here, and also, what is most fascinating or even romantic in a sense is that the two satellites, one of them called Chaser, the other one called Target, will be moving at a speed of as much as 28,800 kilometers per hour. Yeah. And then gradually that velocity or speed will get reduced to just 0.036 kilometers.
Amazing.
Which is hardly. Well, and then the doors will open. So I think we have accomplished in space, which many have not accomplished on the earth. So I think that is what, personifies our goal of going beyond the skies.
Thank you, Jitendra Singh ji, for joining us. Jitendra Singh, the Minister of State in the Prime Minister's office.
Thank you.
I'm going across Dr. Surendra Pal, former Director of ISRO, also on the broadcast with us. Looking at this mission, of course, what is special also is the role of many groups, who've played a key role in this mission, and how cost effective it is. In the larger scheme of things, when we were just beginning this broadcast, Abhishek and me shared a joke, but we discussed how this could propel the start of larger missions. Dr. Surendra Pal, right? Globally.
Yeah. First of all, I wish to congratulate ISRO and the entire country. This is also a tribute to Professor Vikram Sarabhai, whose Punyatithi is there today on 30th December. So this is a technological mission where more than 50 technologies are getting evaluated, and in which most important is, of course, docking, rendezvous, inter-satellite links, and also power transfer. Also, it will be getting, de-docking also will be taking place. Besides that those satellites have been integrated, tested by an industry, which is another, stepping stone in making Atmanirbhar Bharat in the space sector. Another thing which is there is we have developed all the sensors in-house, okay, maybe with the help of industry, our own laboratories, etc. And if you see inter-satellite link, that becomes most important, because if you go for, like a Starlink satellite, etc., there is an inter-satellite link is there. Not only communication, but also navigation, control. We have got onboard artificial intelligence built inside. All those things are taken care. And then, of course, the 24 payloads which are there on the POEM, that will enhance the confidence of the industry, confidence of the educational institutions, and also will pave way for many technological developments. Thank you.
Yeah, thank you so much. In fact, let's get in Dr. S. Venkateshwara Sharma also in this conversation. A very interesting one. I believe the curious minds, the youngsters would be watching every moment, every frame of this launch and what it means for India's march to progress. Mr. Sharma, there was a 2-minute delay in the launch, and that was attributed to the massive traffic in space and the possibility, it was part of the collision avoidance calculation. How much India is contributing to that huge space traffic, and despite all these extra launches, are we good? Is enough space available in space for all this activity? Are we not late?
Yeah, this is one of the biggest questions which is being looked into by all the spacefaring nations, NASA, ESA, JAXA, including ISRO. If you have seen, there are several experiments to decongest the space and also remove the debris. If you see this SpaDeX experiment itself, there are debris capture robotic arm, which is being tried out in this SpaDeX mission as part of POEM 4 restart. I think every country is working towards decongesting in several ways. One is to capture those debris and bring it back to Earth and burn it out, or those debris which are there, which can be shifted to graveyard orbit. It's continuously this activity is going on, and India is no less. It is contributing in all might towards this activity. Apart from this, if you see, the biggest takeaway from this mission is also that opportunity given to many student university. You made a mention regarding the student community, the young generation watching this launch very carefully. I think it is one of the biggest motivating factors for the students as well as the startups. If you see, as well as 10 universities and the startups have been given opportunity. For example, the GLX SQ by Galaxy I, then the SGS Institute of Technology, then the RV College of Engineering, MIT, PS University, and Manaslu Space Agency, Amity University, N Space Technology, etc., etc. This is the first time I think such an opportunity has been given to the student community and the startup community it is going to be a biggest motivator for all the startups and the student community is something which I think is the biggest takeaway. Other point is also that, mating or docking the smaller spacecraft is a big challenge. The bigger satellite, like when you talk about ISS or, Bharat Space Station, it could be much easier when we achieve a greater feat in docking these smaller satellites in space.
Right, sir. The traffic jam in space, Niranjan, is as good as the Majestic Circle or the MG Road in Bengaluru, And
most of Bengaluru is jammed now, Abhishek.
Yeah, and
you can add 100
Mr. B.R. Guru Prasad, Mr. Sharma, I believe, mentioned the poem. There is a poem up in space, and it's actually called PS4 Orbital Experiment Module. But I think what is important is that in a mark of innovation, what is called the stage 4, which essentially turns into debris, is not going to happen. This is going to turn into a sort of an experimental lab up in space for ISRO. Please tell us, what are the innovations that have gone into this fantastic test experiment that ISRO has done today?
Okay. First, let me congratulate ISRO on this successful launch. This is we have to remember one thing here. This is the 62nd launch of PSLV. And, this is the workhorse launch vehicle of India. It has stood by its name. Okay. It worked extremely well. Okay. And, of course, the satellites, the 2 satellites which were launched in the same flight, they have been put into the required orbit. And they are circling the Earth, and they will be made to move away from each other, and again they will be brought back in about a week's time. They will be made to rendezvous, that is to meet each other and to dock. This is one technology which is very, very significant from the point of view of India's ambitious programs like Chandrayaan-4, Bharatiya Antariksha Station, as well as a human landing on the moon by around 2040, and even by 100 years of our independence, having a base on the moon, sustainable one. So to do all these things, whether it is Chandrayaan-4 or Bharatiya Antariksha Station, human landing on the moon, for all these things, launching a single spacecraft entirely in a single launch, that is not going to be easy. So multiple launches will be there. At least in the case of Chandrayaan-4, 2 launches will be there. 2 parts of the spacecraft are launched into Earth orbit, then they are made to rendezvous and dock. And then it will descend towards the moon. It will land on the moon, again collect this rock and soil samples there, again ascend from the lunar surface, bring those samples, precious samples, to Earth. So to accomplish these things, it is very, very essential for us to perfect and demonstrate the rendezvous and docking technology, and that is what is being accomplished in this. Okay, the second thing is POEM. You mentioned about it. POEM, PSLV, PS4 means the 4th stage of PSLV, orbital experimental module. See, 4th stage is not only a 4th stage which put these 2 satellites, SpaDeX satellites, to orbit. There are many experiments, more than 20 experiments are there. Some of the experiments which are flown by universities. Some of them are from like Dhruva Aerospace, that kind of thing, many private sector. And, as was mentioned earlier, as part of Atmanirbhar Bharat, the government has brought in private sector, and this is a classic example of that. How private and government, if they work together, we can do wonders in India. That was government's thinking, and it is going on very well. Yeah. So the other thing is, this 4th stage, for quite some time, these experiments will be done, and ultimately, after all these experiments are done, this stage has to be passivated. That is, it should not become a danger in orbit. We were talking about a traffic jam in Earth orbit, especially low Earth orbit is quite I would not say, I would not be a scaremonger here, but things are becoming very difficult. In fact, but in many of our cities, not only in India, all over the world, the kind of traffic we have, that compared to that, this is nothing. But still, it is a cause for concern. So this stage will be passivated after all these experiments are done, and it will be made to re-enter maybe after some time, because India is very much aware of the space situational awareness, and the need to keep low Earth orbit and the orbits around the Earth in a clean state. And whatever we can do to mitigate the debris, India will do that. I'm sure this is a very good beginning to fantastic thing to cap the year 2024. And I'm sure that it augurs well for 2025 when in about a week this docking operation will be performed flawlessly. Thank you very much.
Thank you for that, Dr. Guru Prasad, Dr. Surendra Pal, and Dr. Sharma. Srijan Pal Singh. Okay, Srijan, last word. I have to take a break. Yeah. Okay, quickly.
15 seconds.
Go ahead.
So, docking is such a complicated process. When the first time it was being done in 1966, it was the Gemini spacecraft and the Agena spacecraft. And it was, of course, a manual docking. We are doing an AI-driven docking, but it was a manual docking. And the Gemini spacecraft, one of those, they started spinning. It started spinning uncontrollably. It took a human hero to actually set the course right and bring the rotation back in its normal order. You know who that very famous human hero in 1966 was? It was Neil Armstrong. Such complicated is the process of docking. It took Neil Armstrong in 1966. Of course, in 69, he became the first person to land on moon. So that is the level of complication we are going to achieve. And of course, we are now going to do it not manually, but algorithmic driven.
Yeah. Thank you, gentlemen, for joining us on this broadcast. Abhishek, we will do a follow-up 7th of January.
Yeah, absolutely.
Okay, taking a break. The debate with Arnab joining us, coming up next, live. Super Prime Time continues. Stay tuned.